Assalamu alaikum, my dear students. I hope all of you are fine and doing well. In our today's video, we are going to discuss about the molar volume. That what does mean by the molar volume. So this term is specifically as related to the gases, and the molar volume is mainly the volume that the gas occupies. If we have 1 mole of any gas and that gas is at standard temperature and pressure, that is known as at ST and P, where standard temperature and pressure, and it is going to occupy the space almost 22.414 dm cube. So dm cube, it is the unit for the volume. Uh, 1 mole of gas at standard temperature and pressure occupies the volume that is 22.414 grams. So this volume we call it as it is the molar volume of the gas. So the molar volume of gas having that volume at standard temperature and pressure. Standard temperature and pressure means the pressure that we have, it is almost 1 atm, or it may be 760 torr. That is the second unit of the pressure. And the standard temperature that we take, it is basically the room temperature. So with the help of this information of the volume of the gas, as the low one, I am having the example 1 mole of hydrogen. It is having the volume of 22.4 dm cube at standard temperature and pressure. And if we have 1 mole of oxygen, the same volume has been occupied the 1 mole of nitrogen. So here all these having 1 mole of gases, but the mass of these gases is different, but they occupy the same space when they are in the ideal form. This is only for the ideal gases. Now, what are the properties of the ideal gases? Basically, the ideal gases are gases where there is no repulsion and attraction between the molecules of the gas, and the volume of one molecule is negligible. When these properties are present in the gases, then the gas is said to be it is ideal at standard temperature and pressure. Next, we have the interesting fact about the molar volume. As the molar volume has been occupied by the gases is 22.414 dm cube of each gas, but they has different masses and the same number of molecules. So here if the gases have different mass but they have the same number of molecules, they will occupy the same volume. What is the reason behind this? The one reason that we have, it is the mass of the gas does not affect the volume. So the mass of gas is not going to affect the volume. So if we take any mass of the gas and it is 1 mole, then it will always occupy the molar volume that is 22.414 dm cube. So this is the interesting fact about the molar volume, that mass did not affect the volume of the gas. So here we have the volume of 1 mole of gas at standard temperature and pressure, where the standard pressure we have 760 millimeter of mercury or 760 torr or 1 atm, and the temperature we have 0 degrees Celsius, and we have 1 mole of helium gas. It is going to occupy total 22.4 liter, or we can say that 22.414 dm cube of the volume. And here we have 1 mole of helium, which is equal to 6.02 into 10 raised to power 23 atoms. As the gas is going to occupy 6.02 into 10 raised power 23 atoms, so it will occupy the volume 22.4 liters or 22.414 dm cube. So this is called the molar volume. Next we have the calculation of molar mass of the gas. So how we can find the molar mass of the gas? So this is very simple. A well-known ideal gas, it is basically enclosed in a container and is having the volume of 500 centimeter cube and at standard temperature and pressure, and its mass comes out to be 0.72. What will be the molar mass of the gas? So we have to calculate the molar mass. Before the calculation of the molar mass, we have to calculate the number of moles of the ideal gas. So to calculate the number of moles of the ideal gas, you guys must know if we have 22.414 dm cube of gas, dm cube, or we can also write it in centimeter cube, that is 22414 centimeter cube. When this is an ideal gas, so at STP it is equal to the 1 mole, and when it is equal to 1 mole, if we have 1 centimeter cube of an ideal gas at STP, then it is equal to 1 divided by 22414, and when we have 500 centimeter cube of the ideal gas, it will be 1 divided by 22414 multiplied by the 500. So we will have its mole, that is equal to 0.0223. So this is the total number of moles for this we have. Next we need to know about the number of moles of the gas. To find the molar mass of the substance, we use the formula, which is mole is equal to, where mole is equal to mass of substance in grams divided by its molar mass. So here we have to find the molar mass. So to find the molar mass, we simply mass in grams, mass in grams divided by moles. So it is equal to the molar mass of the substance. So the mass of substance in grams, we have 0.72 grams divided by its mole, that we have 0.0223. So what will be the molar mass of the substance? So the answer that here we just gain, it is 32 gram per mole. So the gas has molar mass 32 gram per mole, and the gas was unknown, so this gas we have, it is oxygen O2, whose molar mass is 32 gram per mole. So this is all about today's lecture. I hope you guys understand, and if you have any queries, you may ask me about that in the comment section, and I will get back to you guys soon. And the next topic we will discuss about the molecule and ion in detail. For that time, you guys have a good day, and Allah Hafiz.